Hello class, this is Mr. Goodman, and this is lesson 5.3, Translations of the Sine Function. So you've already gone over, or we've gone over in 5.1, where the sine function comes from. In 5.2 we looked at the properties of the sine function, and this here is kind of a rehashing of 5.2. You'll notice here that the way that we communicate this pattern is with y equals sine x, or with function notation, f of x equals sine x, same thing. A couple things about this sine function. The amplitude, the height of the wave, or the depth of it is 1. There it is, 1 right there. It's a height of 1. The period is 360, which means that one full rotation is 360 degrees. The equation of the axis, that's this x-axis here on which it turns. It kind of turns along this line, and we call that the equation of the axis. The domain, it goes in both directions, waving this way and waving that way forever, so it's XER. And the range, it's greater than -1 and less than 1, and equal to them. Maximum value is 1, minimum value is -1. So these are the basic properties of this. What we're going to do today is we're going to graph out the parent function, which is this. Hopefully you're going to have it memorized soon. And then we're just going to translate it, which basically means going up, down, or left, right. This is going to be a pretty easy lesson. And as a reminder, the concept of that up, down, left, right business, well, remember K is up, down, and H is left, right, but H is always backwards the way it appears. Well, that all holds true here. So we're doing pretty much the same thing as we've done before. So here we go. So let's start off over here. Let's start off with our parent function. So a really good thing to be able to do is to be able to actually graph this consistently. And just to tell you right now, sine starts at 0, goes to height of 1 at 90 degrees, crosses back over at 0, goes to -1 at 270 degrees, and goes back to 360. Now, in lesson 1, we went through all of this and how this happens, but for your purposes, well, you know what? Why don't you just have that memorized? And that'll really help. There we go, put a little arrow on the end of it. Now, this actually goes forwards and continues in this pattern, but it also goes backwards too. So, there, 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 and there. There we go. As you can see, I've had some practice with this before. Okay, so let's go and see what the K value does to this parent function. And it's going to be pretty easy. I mean, the only change here is that it goes up 1 space. So every single point that I drew, I'm literally just going to lift it up 1 space. That's it. Okay, and the same thing applies for -2. For time purposes, I'm not going to do it, but everything would be 2 spaces lower. Pretty easy, huh? Did the amplitude change? No. Did the period change? No, that's the next lesson. What did change? The vertical position. That's what changed. Okay. So let's go to the next example here, and we've got not vertical translations, but horizontal translations. I will again draw my parent function because, you know, you need that. And here we go. Always with the sine function, it goes up 1 space. It goes to a maximum first, and then it goes down to a minimum. So it's kind of sometimes easy when you start at 0 to forget which way. That's the way it always goes. Okay, so here we are. And did the amplitude, oh sorry, not yet. We have an H value. H is always backwards the way it appears. So although this says -60, it's really a positive 60. And what that means in this case is that 60 here is 2 spaces, so it's 60, it's 2 spaces to the right. This is 2 spaces right. Again, the reason it's 2 spaces is because I know each space here I can see is 30 degrees. Versus this one here is actually a negative 120. So, and 120 is going to be 4 spaces to the left. So I'm going to do both these because I think it's pretty important. And let's do it. 2 spaces to the right. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. And you can see that we're kind of off the page here, so that when I actually do the smooth curve of this, it's okay to put an arrow there and not get it all the way. And technically this continues, and you'd have to kind of infer what happens next. But in this case, for your purposes, I'm okay with you just putting an arrow on the end and saying that's where it is. And I'm okay with that. Let's do it again with 4 spaces to the left. I'm going to start over here. Oh, this one's going to be hard to see. And I'm doing this relatively quickly to save time. So there's a very good chance I'm going to make a mistake. And that one's off the page. All right, whew, here we go. And where is that one? There it is. Okay. Again, you can infer what would come after this. This would essentially be over here. So this would continue over there. But if you don't know to do that, that's okay. Just doing that is enough. Did the amplitude, and sorry, let's just do this. That color was there. That color was there. Did the amplitude change? Nope. Did the period change? Nope. In the next lesson that'll be relevant. What did change? It's the horizontal position. So that's pretty much the lesson, believe it or not. We can do a little bit of an analysis here of some other ones and say, okay, well, here are some, different different wave functions. Here's our parent function, the period, the amplitude, all these things we talked about at the very first page. And then how does it change? So if I had a horizontal translation, you can see that my horizontal translation changes, but nothing else does. But if I have a vertical translation, then actually the equation of my axis changes. And the max value and minimum value change too. And of course, if I have both, then this one here is going to be 1 space to the left and 1 space down. We can do it all at the same time. So this pink one is what we get. And here are the changes that occurred as a result of those transformations. Horizontal vertical transformations are relatively easy. I want you to be comfortable with this. I want you to do, obviously, the homework. I'll assign certain questions in my cleverly titled Lost in Translations homework sheet. After you do this, the next one is going to be vertical stretches and compressions. And that's what was hard in quadratics is also hard in this. And then we'll actually bring it all together so that you can do all the translations necessary. So that's it. I think I've had a couple easier lessons in a row now, just a matter of just you kind of applying yourself. We're going to kind of pick up speed, not just in terms of time, but just in terms of the difficulty of what we're doing, because I'm running out of time. I literally have to have all of this unit completed by June 17th. So I'm going to be working really hard to make that happen so that you have a viable, complete unit on trigonometric functions. Special feature for today is my oldest book that I have, my oldest textbook. I got a lot of school textbooks, but here's the oldest one I have. This one is Physiology from the Ontario Education Department of Ontario, and it's cost 25 cents, and it came out in 1893. This is a book from 1893. Some girl named Jeannie had it in her 4th grade class in Hamilton, Ontario. And I got it at a garage sale, I think, years and years ago. But yeah, 1893. So pretty cool. Talks about what physiology, at least they thought it was 130 odd years ago, and how to stay healthy, and you know, all that kind of stuff, and really just cool. And I just thought, no, that's something to hold on to. So when it's that old, you gotta hold on to it. So that's it. I hope you enjoyed that. Yeah, next lesson we're gonna get into the stretches and compressions. Mr. Goodman, signing off.